Hi guys and welcome back. In this lecture we're going to create two apps that use edge detection. Okay, so the first one, as we mentioned, is we're going to use edge detection to measure the width of a ruler. And in the second part of the app we're going to use edge detection to detect lanes, or basically do some basic lane detection. Okay, so let's get started. Okay, so first, when you open up Vision Assistant, it will prompt you with Open Up Image. So I want you to click that and then navigate to the rulers folder. And so I want you to select all of these images. It'll show all of them working in this viewer over here. Click Open. And then you should have all the images loaded up in Vision Assistant. Okay, so load up a ruler. Let's start with this one. You can make it bigger if you want, or smaller. Okay, so first, before we get started, we first need to make this image a grayscale. So you can go to color plane extraction, and then you can select any one of the planes will do the job besides this one. So I'm just going to go ahead with the red plane. So now we have a grayscale image. So what we can do is we can go straight to edge detector, and we can draw a line from here to here across over there. So as you can see, it gave us only one edge. We want both edges. So in the parameters, we select first and last edge. And if you look over here, it shows us your edge profile. You can see there's quite a strong edge on the second one because it's quite dark compared to here. It's quite light. So now that we have our width, we want to get our width basically perpendicular to the ruler to measure the exact width. So there we go. Okay, so it shows you over here the position of the XY coordinates and the distance, and also tells you how much noise there is. Now, to measure this distance over here, you can either take this position and find the magnitude away from this position, or a much simpler way is to go to the caliper tool. Now, this caliper tool will only work if you have an edge detector in place. So we just select this one and this one. And then we press measure. And then you can see our caliper tool. We can call this ruler width. And then it will overlay onto that. And you can see the distance is around 45 pixels. Now, obviously, we can calibrate that to real world. If we know the real world pixels is, say, around 5 centimeters, we can calibrate 45 pixels to 5 centimeters, and they'll be directly proportional to each other. Over here, you can just select the geometric feature that we are measuring. But in this case, we're measuring distance. You can calculate the midpoint. So let's calculate the midpoint. It'll show you the midpoint is around this size here. And let's see what else we have. Perpendicular projection, area, center of mass, bisecting lines, midlines, circle fit, and ellipse fit. So these are basic machine vision tools that we can use. Let's go ahead and try this on another ruler. Let's try this one. Now you can see we already have the edges in place. Let's go and see what we're measuring. This one is around 38 pixels. Let's see another one. Just to make sure that it is accurate, you want to make sure it's perpendicular to the ruler. And then go to ruler width. And then you can see we measured 39.12 pixels. Okay, so that's basically how we measure the width of a ruler. Obviously, if you want, you can measure the length of the ruler as well. So over there, you can just make this lengthwise, and it will measure those two sides. Click OK, ruler width, and then measure. Then you can see that this is 221 pixels and long. Okay, let's do some basic lane detection. We've got the image. We can just zoom in a little bit. Okay, we can see this is the original image. We grayscale it. The red plane extraction works quite well in this case. And if you go into the edge detector, throw a line there, you can see we have our edges quite nicely there. But now we don't want just 2 points. We want the entire line. So what we do is we delete this. Delete the ruler width. And now we go into find straight edge. Now what happened here is this thing automatically placed itself. So you can place a bounding box over the area that we're looking for. If you place a large enough one, you can see it detects this line automatically. Let's see what happens when you do it on the side. You can see it doesn't do that quite well. We'd first have to rotate it in place before it detects this line here. This is the red line that it detects. And if you do the same along this one here, it detects that line as well. So if you look at the histogram, we can see that there's a strong peak over there. That is this point over here. That's the point that we're looking at. If we click on search line index, this one will switch between the lines and it will show you what it has detected. So if you go onto this 9th one, you can see there's no lane there. So the line that we detect does not show very well. So what it does is basically it takes a lot of lines, gets the points of the edge, and then draws a straight line through it. And over here, we've got the positions of those lines, and then we've got the average signal to noise ratio, as well as the angle. We can measure the angle and get the coordinates of this line. If you wanted to make a proper lane detection system, you could take this coordinates and then extend this line towards the horizon point. Let's just try this on another image and see what happens. And basically using the same algorithm, we can detect this line here. We can extend it to get a more solid line. And find straight edge. We can do the same on this side as well. And then click OK. And then there you have it, a simple lane detection algorithm. Let's see if we go back one. We have this lane going up there and this one over there. And basically you can see how simple it is to do lane detection or basic simple lane detection in LabVIEW. Look at our performance meter. You can see this algorithm by itself works quite well and quite fast. So if you look at it, it's around 400 frames per second, which is really not bad. But remember, this is a small image. The larger the image, the slower it will become. Okay, so I hope you enjoyed this lecture. In the next module, we will be dealing with some advanced vision detection algorithms such as pattern matching, featured correspondence, optical character recognition, facial recognition, and much, much more. Okay, see you then.